James, I think we may be live, and we've been talking nonstop at each other for a few minutes now. Apologies, technical stupidity on my part. I had my, I think the Lambda provisioned concurrency wasn't turned on, or we had concurrency to 0. So, apologies for that.
Oh, no worries. So, yeah, just for everybody who just joined us now. So today we're going to be talking about serverless observability. So performance monitoring is a really important part of your application. And by understanding the health of your application, you can then know if it's functioning as expected, and then also make decisions to proactively react as necessary. My name's James Bezic. I'm a developer advocate with the AWS Serverless team, but we also have Julian Wood here today, who's another developer advocate on our team, and he's going to talk to us all about serverless observability. So, hi, Julian, how are you doing?
James, I'm doing excellent. After we had spoken to each other for a few minutes, which is always lovely, but yeah, not sharing any of the wisdom over the interwebs would be would be slightly strange. So yeah, I'm doing really good. Thanks for finding us. If you have found us, as you may have spotted, we're not on the main AWS Twitch channel. There's this other service at AWS. S3, I think it's called, or maybe there's a new version, S4, don't know. But anyway, they've 15 years they've been around, literally one of the wonders of the IT world. So yeah, congratulations to them on their 15 years. And there's a whole bunch of information being shown over there. But yeah, we're on Serverless Land Twitch and Serverless Land on YouTube. So thank you. Really appreciate you joining us today.
Yeah. So one of the first questions I ever get asked about this, Julian, is what is serverless observability and how is it different to monitoring?
Well, great question, James. And that's where, people start to think, is this just marketing buzzwords? What's going on? Do we have to come up with a new term? And I like to think of it in a number of different ways. Monitoring is, I think, something we understand. It's monitoring for things that we know are going to go wrong. So this is something like latency to a database, or latency to an API, or how long a function runs, or even in a serverful world, this could be disk queues, or any of these kind of things. These are metrics that you can watch out for, and they're things that can go wrong. All good. We love monitoring. That is great. And what you can do is then you can set up alerts on that. You can watch graphs that go up and get down, and you can understand the things that you know to monitor for. The idea of observability is to take this in a little step further. And observability comes from something called control theory. And the definition is observability is a measure of how well internal states of a system can be inferred by knowledge of its external outputs. It's like, actually, what on earth does that mean? Boil it down for me. Sure. So an application generates data. And this can be data from the platform, from the infrastructure, from your application, from your business, even external kind of things. And the idea is you pump in all these inputs into your application, and you gather as much data as you can. And then what you can do is you can use that data in a number of ways. Yes, sure, of course, you can do it for monitoring. So you can know the amount of Lambda functions that are spinning up, for example, or the number of hits on your API. Cool. That's from an application perspective, from an infrastructure point of view. But what happens if you want to get some more business insights into your application? Maybe you want to know who's signing up for your awesome system in a particular geography, or which part of your applications are being used or aren't being used. Well, these are questions that you want to ask. And in a way, you don't want to have to retrofit monitoring to try and pick these things up. So the idea is through your software development lifecycle, you add more instrumentation into your code and use the instrumentation that platforms like API Gateway and Lambda and everything give you to generate more information, which you can then grab out of and answer any kind of questions you may have. Now, the second part of observability, because I mentioned it was called control theory, is, okay, if I know what's going on, I can then feed that back into my application. So if you've got your DevOpsy hat on, what is one of the big pictures of DevOps? Well, you know what's going on, and it's about short feedback loops. So you can take the stuff you've learned about your application, and you can send those insights back into your application. And this could be from an infrastructure point of view to scale up or scale down something. Or this can be, I'm having a massive sale, and I want to know what my latency is going to be like, and ask a question in Taiwan because that's where we're going to do it. Or I want to know that why are my drop-offs in Europe dropping off between midday and 2 o'clock in the afternoon but at the same time of day for my, I don't know, my delivery app, it's not dropping off in the US. So those kind of questions, and it's about bringing all the data together. Yes, sure, it's all about IT data and application data and the code, but if you think of it a bit bigger, it's about the observability is about also gathering that business information.
Yeah, and actually, we've got a question here from Code with Sean, which actually just ties in really nicely to what you were saying. He's got a workload, but he wants to know how many concurrent Lambda functions have been spun up in response to something happening. How would you see that in the console or in the tools that we provided? And also he's added just here, knowing Lambda utilization to help understand the cost. But yeah, so how would you get a sense of when your Lambda functions are running, just how they're scaling and if they're scaling
absolutely
appropriately?
Well, what I'm going to do is I'm just going to drop in before we continue, because we were asking the question about what is observability. I actually did a reInvent talk last year, which I went into way more detail about what observability is, and I've posted the link and you can go and watch it on YouTube. And luckily for you, I'm actually working on something called a learning path at the moment, and that's going to be coming out in the next month or so. And that is literally a brain dump from me and far more cleverer people than me. And I go into even more detail all about observability. So there's some nuances in there, and there's more than I can just say in literally the 5 minutes we've got on here. But so what I'm going to do is I'm actually going to answer Code with Sean's question with a bit of an example, because that's probably going to maybe bring things to light. And I'm deliberately not using slides in this demo, because I think we want to, if we're thinking about observability and thinking about our application, we're often in the code, or we're in VS Code, we're often in the console rather, or we're in VS Code. And so maybe that's going to make it a bit easier to actually see what I'm going to be talking about. So if I just pop over and I can share my screen, I have an application over here which is called FreshTracks, and my colleague Ben Smith, who is a fantastic skier, developed this application. And basically what it is it's uploading your tracks so you can have a look at them. And I'll show you exactly how that happens. Now, the cool thing is this is a way bigger application. We're not going to delve into it today. It's got connectivity with Auth0, and it uses Event Bridge, and uses step functions, and uses Lambda, and uses API Gateway. What else is there? DynamoDB and whatever. But the cool thing is the source code is available on GitHub. And let me just pop in the actual source link for this application, because the cool thing is you can deploy this yourself, and you can literally go ahead and learn about a serverless application. But what I've added is I've added some observability bits and pieces into it, so you can actually see how observability works in a real application. So just looking at FreshTracks over here, if I go to the home page and my activities, that's not going to make much sense. But what I'm going to do is I've basically got a GPX file, which I'm going to upload. And a GPX file is GPS data. Think you've been skiing or snowboarding or running or rowing or I don't know, whatever kind of activity. And you then into the serverless application, which we've deployed, and you can deploy yourself, I've uploaded this file. And what's happening in the background is it's gone through API Gateway, it's stored on S3, there's some Lambda functions involved, there's some Cognito, there's some Authorizer, there's some Auth0, the front page is on Amplify, you know, in a similar way, there are a whole bunch of things. And in the back end, what has happened is there's also a step functions. And a step functions is then parsing this GPX data, and it is basically pulling out some information and some metadata about this. And then when it's all ready, that gets put into DynamoDB, and you get this cool front end, which is able to view then the tracks you've uploaded. And when this does appear, there it goes. So it says I skied for 52 kilometers. I wish that was me, and does a map of this a day's worth of skiing. And the whole idea is this is all done in a serverless way. There's no servers or anything involved, obviously. And there's a step function state machine, which we'll show, which links together a bunch of Lambda functions. And anyway, a whole bunch of stuff happens. Now, don't necessarily need to get too bogged down into the architecture of that application, but we can already start to just let's have a look at what we can do in this application. And the first thing I want to do is just pop over to CloudWatch. Now, when we're talking about observability, we've basically got two products. One is called CloudWatch and one is called X-Ray. And CloudWatch, as I'm sure you all know, many people have been using it. This just gathers vast amounts of information about our application. And the cool thing is when you're using a managed service like API Gateway, Lambda, or all these kind of things, there are a whole bunch of out-of-the-box metrics that are just gathered for you straight away. So apologies, I'm going to zoom in because just looking over at the correct screen, that's not going to be very helpful. And so there are a whole bunch of just out of the box metrics that you haven't had to do or gather and do anything for yourself. So when this console spins around, and yeah, James and I have discovered that when we're streaming at the same time, some of the consoles tend to slow down a little bit. So please don't think that this is the performance of the console. My CPU is being pegged at 450% via the stream. So anyway, there are two things to look at. One is the per service dashboard. And so I haven't set anything up. And what I can look over here is I can go, I've got API Gateway, I've got all these kind of things. This is everything in my account. And of course, I've got Lambda. So this is then going to be looking at every single Lambda function in my account. And I just had a slight panic when it said no data, but we can see here's a list of all the Lambda functions in my whole account, and I can see some basic data about those functions, things like the sum and the average, and any errors and any throttles that you may be seeing. So already, without having to do anything, I could just literally look at this per service dashboard and go, this is some cool stuff, and I can see what's going on with my functions. So this may already answer some of the questions of, well, how many functions are they invoking? What's the average duration? And all I've done is clicked on a single screen. It's got a list of function names. Helpfully, it's got the runtime and the memory size, so you can use this to spot individual functions. Now I can do the same for API Gateway. I think I'm not going to do it just because things are taking a little bit of time to appear on the dashboard. So that's for one service, Lambda API Gateway. But what I can also do is I can then look at a cross-service dashboard. And then this looks at all the services that are being used within this single account per region, obviously. And this is going to look at, for example, this is some API Gateway specific things. You can see I've got some average latency that it's showing.
Julian, just a quick question. Is that in metrics, the previous screen?
This is literally in the home of CloudWatch. Okay. So I'm not actually deliberately going into logs, metrics, or anything. I'm literally just going into the root of console.aws.amazon.com/CloudWatch. And this is the stuff that is already just front and center. I don't have to go and look for anything. Great. Thank you for that question. That's good to spot where these things are. And anyway, I'm going all the way through. Here's Lambda. And so this is looking, across basically everything that's happening in my accounts. And so this is also a really good idea when you just want to have a look around and see maybe where you want to delve a bit deeper. Obviously, with a bit of a busy account, things can get lost. So there's a thing called a resource group, which you can create. And I've created a resource group for fresh tracks. And so this helpfully is just going to create a filter basically, and only just show me the fresh tracks things. Now, I'm sure everybody is doing best practices and you're only using one application per environment for AWS accounts. I am joking, I promise you. We obviously know people can't go do that. So this is, if you do have a busy account, this is a way that you can just get some information. This is now just for fresh tracks rather than everything that's going on in my application. So that's just looking at the dashboard. But now you mentioned metrics. So well, metrics is something we can then delve in a little bit deeper, and we can go and look at the metrics that are created from my application.
So, quick question on that, Julian, yes, before you move on. The resource group you're showing us, is that created in CloudWatch or somewhere else?
That's a good question. I believe that is based on either tags or a CloudFormation group.
Yeah, there is actually a CloudFormation group, yes. And you can in SAM as well. You can do that. Yeah.
So you can in fact do one or the other, and so you can either create a resource group via tags, or you can create a resource group via CloudFormation. So actually, seeing you do mention that, there's no reason not to just jump into SAM. So SAM is our infrastructure as code tool, and it's basically doing a transform for CloudFormation, and just easier way to do CloudFormation. And if I do look into this somewhere, I do have, there we go. So I think I'm actually, for this example, I am using tags for this example for the resource group rather than CloudFormation stack, but you can do either. So those metrics are all good, and I can, sorry, I was going to jump in, and I can look at these kind of metrics over here, and sure, I can look for individual functions, and I can look for individual API gateways, and delve deeper and deeper into what these things are doing.
Just a quick reminder to everybody who's just joining us that today we're talking about serverless observability using Lambda-based applications, and Julian is talking us through all the different services and features you can use to add observability to your apps.
Thank you, James. So yes, so I'm just going to go back to the CloudWatch homepage. You can see that will refresh with any new updates that are coming along. Now, those out of the box metrics are cool and they're super useful, and they're going to tell you some basic information. But generally, we also going to want to create custom metrics from within the application. And the custom metrics are things that are specific to your business. So yeah, sure, there's going to be maybe latency to DynamoDB, or there's going to be something involved with API gateway. But think of those as the platform logs or the AWS logs, which is at an infrastructure kind of level. When you're thinking about custom metrics, these are things that are important to your business. So what do you need to start gathering from your application that is important to your business? So seeing we're running a moderately successful fresh tracks application, maybe something we want to start gathering is, well, maybe how many tracks are being uploaded. That could be interesting. So we want to know, for example, who's uploading tracks, maybe where they're from, and maybe that is going to be something that is going to be one of our business metrics that we are going to look at. So just switch over to the screen. Yeah.
Actually, Sean makes a good comment here that I noticed this the other day as well. Like, he said he's been missing out on some things that are right in front of him. And I feel the same way when I started looking into this more. There's actually a lot of different tools and services that are hiding in the menus. So what's the best way to find them, Julian? How did you come across and know which ones to apply?
The funny thing is you're absolutely right, because and one of the problems with AWS, I'm doing in inverted commas, is because we are rolling things out all the time. There are these little tips, tweaks, features, additional things that are being added to the console and obviously to CloudFormation all the time. And one of the things that I do is often when I'm looking at applications, I do like to just go into the console and to have a look around. And that's what's part of the idea of this session was, yeah, sure, we could look deeply into code and we could look into CloudFormation and this kind of things. But having that visual look of just looking around the console, and a silly thing, for example, Metrics Explorer. Ah, that's new. Container Insights. Ah, that's new. Lambda Insights. Ah, that's new. So use the console with some of the pop-ups that appear on the top and some of the new things that appear on the side to sort of explore what is available, because hopefully you're going to be pleasantly surprised. And we're going to, as AWS evolves, we're going to keep adding more features. We're going to keep adding more functionality. And some of that functionality is stuff you really haven't even thought you may need. And it's going to be super useful. So just heading back into the code, I'm talking about custom metrics. And this is one of the Lambda functions. Don't need to get into so much detail. One of the Lambda functions that parses that GPX file and grabs some info out of it. And simply what I do, this app is in Node. I think it's Node.js 12, and all this does is require the AWS embedded metrics. And the AWS embedded metrics is a Node package, and that allows you to create metrics using the embedded metrics format. Now, there are other ways to create metrics, and you can call the put metrics API directly. You could also write to console.log, and then you can view the logs and everything. But I'm going to show a better way to use the AWS embedded metrics format, which is going to write things into your log files, and then the metrics is going to be able to pull things out of that, which is super useful. So all I do here is I add the AWS embedded metrics, and then basically I wrap my function in this metrics aggregator kind of thing. And I set a namespace, which is, fresh tracks. And in this example, I'm just going to be looking at cold and warm starts. So I'm just putting a metric for cold start, putting a metric for warm start. You don't have to do that, but this was just showing an example. And then further down over here, I'm then putting my custom business metric, which is tracks uploaded. And that's just one, and that's just a count. So every time a track is going to be uploaded, this is asynchronously going to put a metric saying tracks are going to be uploaded. Now, embedded metrics format is nice because it's asynchronous, while some of the other ways of doing metrics within your Lambda function, you land up writing to an API and waiting for a response. And sure, if they're small metrics, it's not going to take a lot of time. But if you've got a whole bunch of metrics, each time you are updating a metric, that's going to take time. And in a synchronous Lambda function, you don't want to be wasting time within your function.
Julian, so when you
yes.
say it's asynchronous, going a little deeper on that, why is that useful?
Well, so what I'm going to say is that when you do asynchronous metrics, what it does is it bundles all the metrics up, and then all it does is it sends the metrics to CloudWatch, and CloudWatch responds going, yeah, got them. And off you can go, you can carry it. CloudWatch then on the back end carries on doing all the processing and making sure that the metrics land up in the right place within the CloudWatch service. So it's really quick to be able to put your metrics. CloudWatch just responds, I got your metrics. I got you covered, 200, you're all good. And your Lambda function can carry on. So it's a way that you don't have to wait for things. So synchronous, you do a request, you say, I want something, can I have a response? And you wait for that response. Asynchronous is, I'm telling you I've done something, off you go and do your kind of thing. You just tell me you've received my request. You don't actually need to respond with anything back to me in terms of data, which is more efficient.
And Sean actually made notes here that with custom metrics, this is an interesting way of pushing computed data somewhere outside of the application.
Exactly. So this is one of the big use cases for embedded metrics format. Now, people have done this before, console.log in Python or whatever kind of things, and then they would build these things that would parse these separate applications that would parse things out of your logs. And you could, you'd have to write things to a Kinesis stream and then read it from Kinesis maybe, and then do some string handling and and then write things off into CloudWatch metrics. With embedded metrics format, all of that goes away. This is just automatically going to be able to create some things from your metrics. So pretend we have, well, we don't even need to pretend. We can actually, why don't we just upload some more tracks? And we are going to drop that into there. This is going via API gateway. Step functions in the back is doing its magic and is computing all the information based on that information. So what I can do here is I can go into the CloudWatch metrics section, and I can pull up the metrics, let's just say even for the last hour, so it doesn't have to grab too much metrics. And we can see here, let me jump back to my code quickly, where we set up this namespace called fresh tracks. Well, voila, the namespace fresh tracks is over here. So this is a nice way that you can organize your metrics. And I can go into all the metrics that have been created, and this is going to pop over here, and why don't I even copy and paste? So I had this metric which was called tracks uploaded. So I can simply look, just by searching in the console here for any metrics that are gathered for tracks uploaded. And the searches, and there we go. So I have a metric that I can now plot. Do I have no metric information? That is not helpful. Of course, when I looked at this earlier, I had loads of metrics uploaded. That's not appearing, just because you're doing a live demo and it's here to annoy me. But anyway, what would happen? Let's see if I can actually ping something else, because that would be very silly not to have a metric that doesn't work. So, okay, How does
the tracks uploaded metric appear though? Because it's obviously not something that's part of AWS.
Well, so it appears. So in fact, let's see if any of these appear. I'm just going to do the one out. They all appear in the same way as a custom metric, and in a way they appear exactly like an AWS metric. And this is not. I'm quite stumped why this is not. Why none of these appearing? Because obviously we've just created some data. Let's see if I can grab any. So I'm literally grabbing now 36 metrics and popping them onto the screen and hoping, we do have a metric over here. So what this green one, something has given a metric which is useful. So I can zoom onto that and I can get some more details. And this is actually the one that is saving a database record. So at the moment I'm looking at it at a line, but what I can also do is I can look at a number, for example, and this is going to whir around, and this is then going to tell me So this fresh tracks get activity, and if I was to hover over there, this metric would be 1. So pretend, don't know what's going on with tracks uploaded, but pretend that that number would be tracks uploaded. And so I can slice and dice to my heart's content. I can say I want to do, all these different kind of numbers, all these different kind of actions over time and everything. And basically I can plot any custom metric in the same way as the Lambda service would be creating default metrics for Lambda invocations, for example. And they just appear over here, and you can see the metric name is warm start, cold start, and you can see the tracks viewed and tracks uploaded. So everything is just right over here. But that's also some searching. So if you do want to find another way to look at metrics, is this also the handy metrics explorer. And this is pretty cool, because what I can do is I can look at I can look via Lambda, for example, and all Lambda function metrics. And what this is going to do is this is going to allow me to explore the metrics. I was trying to think of a clever kind of thing, and then I'm looking over and it's called the Metrics Explorer. How can you better show that? Well, it explores the metrics. So this is a way I can literally look at a whole bunch of different kind of things. So for example, runtime. We know that runtime's going on. I want to maybe find my Node.js 14 Lambda functions, and off it goes. It's going to, pop up any of those metrics over there. So this is a cool way that you can actually explore your metrics and even find out what kind of metrics you may have that's available. And also, the fresh tracks metrics are also going to be in there. And then you can graph to your heart's content. I think I'd said that already.
Yeah. So for anyone just joining us right now, we're talking about serverless observability with Lambda-based applications. And Julian Wood and the DA team is walking us through the Fresh Tracks application to see how you can monitor what's going on under the hood when the application's running.
Excellent. So another thing what you can do is you've got all these metrics, you can go and create alarms. Now, I'm not going to do that just because I don't want to run out of time, but basically anything that has a value, you can go and you can alarm on. And you can set that to email you or page you or kick off some other workflows or do anything. So quickly, I just want to show you Lambda Insights. And Lambda Insights is a way that you can get even more insights into your Lambda applications. And what this basically does is pulls more information from your Lambda function. The way it does that, and that's out of the scope of today, is that it uses a new functionality called Lambda extensions, and it basically bolts an additional piece of code onto your Lambda function, which is able to pull more data than the Lambda service can get from your Lambda function. Because remember, the Lambda service isn't able to view inside your code. So the Lambda service is not able to see some things from within the isolated execution environment that Lambda runs, because that's where your code runs. But Lambda Insights can. And for example, something you can't get with normal Lambda is the network usage. So something you always thought, oh, that is very strange. I don't know how on earth I would be able to find the network usage of my function. Well, using Lambda Insights, network usage is one of the things you can now actually view, and you can see the graph here, which is doing network information for my Lambda function, something you couldn't do before.
So Julian, a couple of quick questions for you. The first one is from Michael. Can you show the code you're using to create a cold start variable? He didn't know that was trackable. How do you get cold start information?
Okay, certainly. I will cover that. What I will say is Lambda Insights actually checks for cold starts by itself. As you can see here, this is really showing the number of invocations, the number of cold starts, and the total cost. So look how cool this information is, that even though I am gathering cold start information, with Lambda Insights, you don't have to. It can do it itself. And I'll show you how to add Lambda Insights. Lambda Insights is not an additional charge itself as a feature, but because it's going to use a bit more CPU and memory for your Lambda function, your duration will increase. And so there will be an additional charge, but it's bundled in with your Lambda function. So I will go back to my code. And I promise you're going to be bitterly disappointed with how the cold starts are done. Basically, what I do is I say I define cold start to be true in the beginning outside of my function handler. And so as soon as the function initialization code runs, cold start value is going to be set to true. And then if it is true, it's going to put the metrics for cold start. and then set cold start to be false. So next time for a warm execution of the Lambda function, this variable is already going to be, because it's set outside, it's set within the same reusable execution environment, that is going to be set to false. And so next time that means that the warm start is going to be 1. So
that's a great example of a custom metric.
Yeah, and there's nothing clever from Lambda. I'm just creating this. I'm using my knowledge of how the init and how the handler code works to be able to inject this cold start. But as I say, now with Lambda Insights, you don't have to do anything for yourself. And Lambda Insights is added. This is another thing. There's so much to talk about, James. We could go on forever. This is the new Lambda console as well. I'm not sure if you've realized or been into it for a while, but the Lambda console is at a big uplift in terms of functionality. Remember, there used to be a single page with just loads of stuff, and you used to scroll for hours and hours. Obviously not quite, but it was all in one place. So what they've now built now is a much nicer navigation way that you can sort of navigate between different things without having to go mad. Yep. So where am I looking for?
So one quick question here is about using Lambda power tools. So what we're showing you here today is really how you do things without any additional frameworks or anything else added on, but definitely you can use power tools and some of the other third-party tools that are out there.
I will cover power tools shortly. Hopefully we'll have a time. In fact, I'll make sure we have time. So where are we going? So if you go into the Lambda console configuration, monitoring, and operations tools, there's a thing called enhanced monitoring. And obviously, I don't need to turn it on. And enhanced monitoring is CloudWatch Lambda Insights. It's not Log Insights, it's Lambda Insights. And so what that basically does in terms of the function configuration is it adds a Lambda layer, which is the Lambda Insights extension, which just gathers the stuff for you. Don't have to do anything. You just simply toggle that checkbox, and that is all done. So there you know. Now you know that you can gather even more Lambda information than you expected. So let me see. I think I'm going to jump into some logging things now. Now, let me see. I want to try and I'm just going to bring up the slide. I did say no slides, but I just want to show that all these serverless services have a whole bunch of built-in logging available. So, API Gateway and Lambda has got a whole lot of different ways that you can actually create log data. And I talked about creating logs, from the embedded metrics format. So this is the CloudWatch embedded metrics format, and it's for Node and Python and Java. And what that basically means is what is structured logging? Okay, it's structured logs. That sort of makes sense from an English language perspective, but what does this mean? Well, if we have on the left-hand side, we've got the structure of JSON embedded metrics format here. And you can see this, what basically happens is we've got a message that's from the side, and this may be an event in your application. And on the right, what is created is JSON structured logging. And so what you can see is that's automatically, embedded metrics format automatically adds some function information and then creates an automatic namespace. So in this example, it would be fresh tracks. And you could, you could create these dimensions and these kind of things as I showed in the code. And this is a good way to categorize your environment. And then your metrics over here. So we've got a price in cart and a quantity in cart. And that's information from my function invocation, maybe from the event, maybe from the response or something. And basically on this right-hand side, you then build up these metrics. And as you saw in the code, you just send these metrics off and it's all done. And the cool thing is Lambda is going to have the Lambda function information. It's going to have the namespaces, so you can have dev and prod environments separately, and then any kind of metrics which is put. So that's why it's called structured logging, because it's instead of just doing something to console.log, which we would do, where was the previous example on the previous slide? Something like this, that message you would just send to console.log, and it's got all of that message information. But yeah, it hasn't got any of the Lambda function information, and it's not as easy to then parse and pull things out of that. So that's the sort of idea of what the embedded metrics format is. And I will just post the link because there are the clients for Java, Node, and Python. The link that's being popped there has got that information. So we all know with our logging, I've shown the embedded metrics formats. I did it sort of a bit the wrong way around, but I wanted to show it even though, because the embedded metrics format is created from logs. So you create the logs and then the metrics are created, but actually it's simpler to show metrics because it's part of the standard service. So please forgive me for switching things around. I'm hoping it just makes a bit more logical sense. But something I do want to show you, which is very simple and very cool, is if you've got the AWS toolkit for Visual Studio Code. So this is the AWS toolkit for Visual Studio Code, which is an extension for VS Code. And something you may not realize is where am I? I'm in Virginia doing this application. What you can do is in VS Code, I can look at CloudWatch logs directly from here. The demo people are out to get me. Let's see if I can quickly switch to another account. Saved by the. So within CloudWatch logs, what I can do, within the AWS toolkit for Visual Studio Code, I can browse using the AWS Explorer, CloudWatch logs, and I can view the log stream that has come out and view my logs directly from within VS Studio Code. So that is super useful, super useful. I can go and I could, I can invoke a Lambda function directly from here. So if I'm doing some rapid testing, it's uploaded to the cloud, that's fine. Or very easily, I can then go and grab the logs from the CloudWatch log section. So that's
how do I get the IDE widget that you have there?
Yes, you can just you can install it. I'll put the name in. That's the AWS toolkit for VS Code. So by the power of the interwebs, you'll be able to do that. So that is such a small little quick tidbit that is just when you see that you're like, oh, how nice is that to find?
That's great. Yes, it does work for Cloud9 as well.
Oh, brilliant! Yes, it does. Yeah, that's some new functionality. So quickly, because I've got two more things I want to show. The other one is Log Insights. So now Log Insights is a query and analytics tools to be able to look across a number of your logs. And the cool thing is it can also pull out those metrics from your logs. So a lot of functionality. If you think of it as a sort of log query analysis, you can select up to, I think it's 20 log groups, and then you can, anything that's in those log groups, you can pull things out. So I've got some examples over here, and I'm just going to look at all errors, for example. So I will post these code snippets, and I've actually got a website that has all those of course, I need to select multiple log groups. So how about we just do fresh tracks? Now, fresh tracks hasn't been behaving particularly well. So let's just hope, well, maybe we're going to see some errors. If it hasn't been behaving well, maybe that's exactly what we need to see.
What is a log group, by the way? How is that different to a log stream?
So what happens, let's just talk Lambda specifically, but this is for a lot of AWS services, that when a log group is a sort of collection of where log streams are added. So a log stream is a single invocation of a Lambda function. If there are warm invokes, it goes to the same stream. So it goes to the same stream. So each time a Lambda function runs, it's going to write a stream of data to CloudWatch logs. Each concurrent Lambda function is then going to be a separate stream, and those are then aggregated within a log group. So a log group is a gathering of log streams.
Right. Is
that good enough, James, or do you have a better?
No, I think that's pretty good. It's just we often talk about it. I don't think we really say what it is.
Yeah, good point. And of course, we're not grabbing any errors over there. So anyway. Let's see. I wonder what else would be generating errors. Anyway, within Log Insights, there's a whole bunch of different queries you can run. So for example, this is like cold starts and init duration. And I have an error in that, which is going to be, what have I done? No. Well, it looks as though it errors, but it's gathering some data over here. So anyway, so this is the init duration. So this is the cold starts that I'm just pulling out from the logs files. I've got the average init duration, the max init duration. So this is just looking at my init code. So this really quickly, just pasting in that query, I can look at all my Lambda functions based on fresh tracks. Like, why is this one taking a long time in init, or why is this one being really quick in init? And this can be a troubleshooting step to maybe know where I can optimize my initialization step in my Lambda functions.
So just to be clear then, you're querying here then across multiple log streams and multiple functions.
Yes, so because each function is sent to a log group, I am selecting multiple log groups, up to 20 log groups. So you've got a serverless application, 15, 20 Lambda functions. I can look at the logs of all of those Lambda functions at the same time. So that's super useful. Instead of chasing around to the individual log groups, especially where you've got a distributed application and you've got multiple Lambda functions, not necessarily chained, but one Lambda function maybe do X, one Lambda function may do Y. To have to go to each of the individual log groups can be painful.
Yeah.
While here, I've got a way that I could look at 20 log groups in one place. What I'm going to do is I'm going to post into the chat, which is some log insights examples, and some of them I've created, and actually some of James has created. I don't think he knows yet. I've linked them and put them on a GitHub repo. But yeah, log insights are super useful. I've just done some very basic log queries over here, but there's a whole bunch of stuff that you can query across all these different log groups.
Great. And in the last 15 minutes we've got, we're here to answer any questions you have. So if you think of anything you wanted to know about observability with Lambda, now's your chance. Just ask them in the chat, and Julian and I will do our best to answer them.
Yeah, absolutely. I think what we'll do is we sort of we'll carry on, and please, any additional questions, bring them on. Yeah, we're certainly here. So one other last thing I just want to look at is for tracing. And so X-Ray is the AWS tracing solution, and this is all about tracing requests as they flow through your application. So a transaction that may go through API gateway into a Lambda function, through DynamoDB into a step function, or something like that, is going to generate, pass through all these different services, and X-Ray is a service that is going to be able to connect these different things together. Because obviously we can look at log groups for all these different functions, but we really want a way to be able to visualize and look at my application. So there are two ways to look at X-Ray, and I'm going to look at the sort of newer way, which is a part of CloudWatch, which is called Service Lens. And Service Lens, if you've ever used X-Ray, there's a thing called the Service Map as well. And Service Lens aggregates all the data from CloudWatch logs and the information from X-Ray in quite a sort of handy user interface. And this is a really great tool. Before, when I've been looking at the metrics, and I've been looking at the logs, and I'm going to be looking at the traces, this is sort of a one-stop shop for getting that information from your serverless applications. So as we can see here, the service map is being slowly populated. And what I can do is I can zoom in or out. And what X-Ray has done is it has basically created this map or this graph connecting all the parts of my application. And that is pretty cool, because I haven't had to set up any of this myself, other than turning on X-Ray, which is turned on for API gateway and is turned on for Lambda functions, and step functions and other services. So there's a process to turn that on, but it's really simple. And then X-Ray starts automatically connecting all these pieces together.
Now, this is really interesting. So I don't then have to go through multiple log files. I can basically follow a transaction using a visual graph.
Exactly. And I'm going to show exactly what that looks like.
Right.
So what I've done is also, I don't know if you saw, there's an X-Ray group, which is slightly different to what we had before with Lambda. And you set up these X-Ray groups within here. And basically, this is a nice way also to limit my application, because, when I zoomed out before, it looked a bit hairy and there was too much. So this is now the view of the whole Freshtracks application. And immediately looking over here, I can see that API Gateway has got some errors. So without having to know where to look or know that or know what's happening, I can just look at API Gateway. And I can see that, there's immediately some latency and some requests and the faults and 19% errors. I've got 4xx errors. What's going on over there? So that's API Gateway. I can also select, let me just do that before I do click out. If I've got an API Gateway talking to a particular Lambda function, I can hover over a Lambda function, and this is going to give me some latency requests and faults and other general information. So back to my API Gateway, I can view over there, and immediately for API Gateway, I can see some latency information, the number of requests that are flowing through my application. There are no 5x faults. There were some other kind of faults. So what I can do is I can jump to the dashboard directly, which was when we started this hour. We were looking at that sort of dashboard view of just API Gateway. That would jump over to that. I could jump to the logs, and that would then jump to the CloudWatch logs groups. This would jump to log insights, and you'd be able to use log insights to query API Gateway. What I'm going to do here is I'm just going to look at the view traces. And so for API Gateway, this is going to, has this not, oh, there we go. I'm actually going to, let's see if I just reduce it to an hour so it doesn't have as much data together. And so this is now, Service Lens from the service map is now going to be gathering data from X-Ray. And the handy thing is over here is what I can do is I can then look at different HTTP methods. I can look at response status, and these are a whole bunch of different filter types I can do. So I can look at my faults, for example, any errors. I could look at the user agent. So for example, I have, from Chrome or Firefox, and what I can do is I can just add filters to narrow down to things I maybe want to find things about. And this, you can see along here, from client IP to URL to response code to whatever. But what I want to know is we did have the 4xx errors. It's not popping up over here. As I said, the errors are not being generated in the right place, which is very annoying because you always want the errors at the wrong time. But anyway, I'm going to show you what this is going to look. So this has brought back 34 traces, and this is also handy, a response time distribution of the traces. And you can see here P95, P99, which basically means 95% of my responses are coming back in sort of between 3 and 4 seconds. And 1%, the leftover from P99 is coming up at 4%. But we can actually see that half are appearing over here, which is very quick. So this is also an indication that there is going to be an error. I'm very surprised I don't have any errors though. This is unless that's coming over here, it's not. So let's see.
Good question while we're waiting there is,
Certainly.
Can we get the API keys for API gateway in the Lambda function? Good question.
That is a good question. That is a good question. I don't
turn
know
on
if that's
API gateway
automatically.
logging. I believe you probably can, but we should check that.
We can show something now. So yeah, thanks you, Bagar1251. Yeah, tick the error checkbox may help. I was wondering why I wasn't seeing that. Thank you very much. And again, this filter is over here, and here we go. we have got the errors. So this is a 403 response code. And this is now going to be populating the trace, and I can see immediately. Now, I haven't jumped out of Service Lens. I'm still within Service Lens, and just with a couple of clicks, I know I've got a fault, and I've got an exception, which is user is not authorized to access this resource. And look at this, super helpfully, I've got the logs right within here. I haven't had to jump to CloudWatch Logs Insights or jump to CloudWatch Logs to get this. And I can look over here and I can see what is that error. The client is not authorized to perform this operation, and I can go and troubleshoot that. I happen to know that this is cause, so no panic. I know what's going on in the application.
It's always cause, isn't it?
It's always cause. So what I'm going to do just for part of time is I just want to see if I can go back, and I just want to look at what a successful filter looks, successful request looks like. And while my console is behaving pretty slowly, okay, there's a GET request. So if I look at a GET request, I'll pull that up. Did I not select that? Let's pick any GET request. Sorry, console. There we go. Console is catching up with what's going on.
Oh, we're waiting for it. Well. I have a quick question. So do you have any suggestions about observing step functions express workflows in the same way that you can for standard workflows? Any good guidance on managing step functions express workflows? Yeah,
I don't believe that a step functions express workflows has X-ray support yet. I think it's only the same. And in fact, I'll show you that shortly after this. Yeah, I think your best bet is, as with each things before X-ray, you've got to do logging and tracing a bit sort of manually. Now you can add tracing data within anything. It may not just be as joined up as you would like to have. So yeah, sorry about that. So yeah, this is what's called a waterfall timeline. And so this, I can see that this request is going through API gateway, through the Lambda service itself, through a Lambda function, and I can see that Lambda function is invoking DynamoDB. And this is literally looking at the individual trace. And so yeah, just to pause on that, I don't want to flick over that. This is the timeline of everything as it's going through your application. Yeah, through Lambda, and I can even see the individual calls to DynamoDB. I didn't cover in the code how that is actually happening. Basically, what you do is you swap out the AWS SDK for an X-ray SDK, and then stuff is automatically captured by tracing. So very simple. Instead of just calling the normal AWS SDK, the AWS SDK is swapped out for this AWS X-ray SDK core, and then any further calls to AWS.DynamoDB, for example, in this example, is traced automatically. So sorry for not covering that. And again, look at the cool thing over here. I can actually see now the API gateway execution logs, and I can see the Lambda logs all in a single place. So super useful when you are now troubleshooting a distributed application. I can have all these things jumping over here. Now, time-wise, we are running out, but I do want to show you one thing that's also cool. And because we were talking about step functions, if I look at my state machine, I can look at my state machine, and if I view the traces now on a step functions state machine, again, we're all within the service lens lot, and it's a service lens console, and it's got jumping off points to logs and X-ray analytics and all kind of things. So let's see, I've got a whole bunch of traces. Here is a state machine execution. So this is a successful execution. How nice is this? I now have a graph to show my step functions, and there are a whole bunch of different Lambda functions, and I can, I can hover over them and I can see how long things are taking. If there were any latency errors or faults or this kind of thing, this would be graphically showing over here, which is useful, as I showed before with the API gateway. And here we can look at this. We've got now a step function state machine, which is calling a parse GPX Lambda function. It's calling a save track to database Lambda function and another publish to IoT Lambda function. And so I am literally looking at a state machine, which has got 3 different Lambda functions it's calling before finishing. And I can see all of the time that this whole state machine is happening, because the X-ray information is being passed between all of these. And I know, for example, if I had an error writing to S3, that would pop up over here. I can see that it's a get object. For instance, if I had a permissions issue or something like that, I'd be able to spot it right over here. Haven't had to jump to S3, haven't had to jump to my Lambda function, haven't had to jump to anywhere else to see all this information. And again, helpfully down here, I now have the logs from each of those 3 Lambda functions all in one place. So that is super useful, looking at a state machine now within the service lens and X-ray, and I can now look at all those 3 Lambda functions and look at all of their logs. Super simple and easy.
Very interesting. We have one quick question here. How to keep Lambda functions in a warm state? Is it possible?
Lambda functions, it is always possible. There are 2 different ways to think about this. One is that you should architect your Lambda functions in a way that things can be done in the cold start and then they're ready to go. The more Lambda functions you run, the more warm start Lambda functions you're going to hit. Basically, it works that for each concurrent execution of a Lambda function, a new Lambda execution environment is spun up. So this freaks people out when they're doing their testing and they testing things out and they go, oh my word, every single time I invoke a Lambda function, I'm getting a cold start. When you ramp up into development or into production, the more your application is used, the percentage of cold starts reduces dramatically. And that is super helpful and good for you to know. So that's one thing. The other thing is, if you do have latency sensitive applications, particularly behind something like API gateway for something synchronous, you can use something called provision concurrency, which basically pre-warms your Lambda functions. And you set the number of functions you need and it pre-warms them, and you can set them on a schedule to do that. So that's the quick answer. There's lots more to go into, but yeah, those are the 2 different ways, is to understand that the cold start issue is way less of an issue, certainly as it has been before. The more you use your application, the less issue it will be as well. And if you do need to pre-warm your Lambda functions, you can with provision concurrency. So Code with Sean, you've got a question about the Lambda starts up in 125 milliseconds or less, correct? It uses a microkernel, if I understand.
I answered that one in the chat, actually.
Did you? Okay.
Yeah, just on that though, cold start latencies do vary. They're influenced greatly by package size, but they tend to be in the hundreds of milliseconds. Yeah.
Yeah. But the point is, each Lambda function runs in an isolated, secure environment that isn't shared with any other Lambda function, let alone any other customer. So your Lambda functions is literally an isolated, it's not actually a container in terms of a Docker container. It's actually in a thing called a Firecracker VM. So it's actually in a small little virtual machine that spins up super quickly and is super fast, but is isolated from everybody else. So when you're talking about microkernel, yeah, lots of different ways to think about that.
Hey, Julian, we've only got 2 minutes left.
We have. I did promise, and I didn't want to do that. The power tools. Let me see. Yeah, Lambda power tool. Power tools is a cool way to. Where I did have a slide quickly on power tools just to show. So we only have 2 minutes. Can't find that. Anyway, Lambda power tools is a bunch of libraries and utilities, which is for Python and for Java. And this is written by the community with a lot of help from AWS. And these are easy way to add metrics, logs, and traces into your Java and your Python applications to be able to add a lot of this observability and take the heavy lifting away from you. So the links are over there. Certainly go and have a look if you are doing Java or Python. That is a great way to be able to get to be able to add observability into your code without having to write a whole bunch of stuff yourself.
Yeah. Well,
another thing before we quickly go, there's a workshop. There's actually an observability workshop, observability.workshop.aws, and that has got all information about. It's a cool thing because you can play by yourselves and you can just learn about observability.
Well, that's great. Well, Julian, thank you so much for showing us everything. That's really insightful, showing all the different observability tools and the different places they're in. But it's probably a good time to also mention, if you want to learn more about serverless, you can visit serverlessland.com. That's our DA resource where we bring together blogs and videos and other learning path resources. Also, you'll find office hours and the schedule of upcoming office hours, which are every week here on Twitch and on YouTube. But once again, thanks very much to Julian. If you have any questions at all about serverless, reach out to your DAs on Twitter, email, LinkedIn, any channel you prefer. And we'll see you again next week.
Thank you very much. I appreciate you taking the time. It's been great fun. There's so much to talk about observability. There'll be more content coming out as well. Yeah, hit me up with your questions. And yeah, same time, same place next week for even more cool stuff on serverless. Thank you very much. Bye-bye.
Bye.